general formula today that helps us find the value of this stuff, but honestly, there's going to be specific formulas relative to what we're talking about. Guys, if you recall these notes right here, this looks very similar to the last section of notes, doesn't it? Yeah. Okay, now right here, guys, in this section right here, 9.6 volumes of prisms. Goal not so much to count the number of units on the outside, but the number of units on the inside. And I already see a mistake right here. It's not the number of, remember we drew squares there on the outside? What were we putting on the inside now? Okay, so what kind of units are we talking about in this section now? So I don't want to hear square units anymore. I want to hear cubic units. And what exponent or what value for an exponent is going to represent cubic units? A 3, right? Okay? All right, so I'm going to have number of cubic units right here on the inside of Prism. All agree there? Okay, so it's just like this. It's just like this big cube right here. I want to know how many of these little cubes right here can I put in there, packed together adjacently to fill this up completely. That's all we're talking about today. So guys, we already know what a prism is. Right here, volume, number of what? On the of a prism. Okay. We should be able to spit these out real quickly. Base formulas to recall. Okay. Rectangle, what is it again? Okay, our length times a width, right? Everybody agree with that? Trapezoids? I just want to jot these down again. Guys agree with that? Guys agree with that? Okay, triangle. Okay, half of base times a height. Okay, circle. This is the toughie.
The radius.
To the second times what? So 3.14 times radius squared, right? Pi r squared. All agree there? Everybody agree there? Yep. So if a full circle is 3.14 r squared, wouldn't half a circle be the same thing divided by 2? So like go 3.14 radius squared, divide that by 2. And again, we should know those. That should just be on the tip of our tongue at all times, okay? I sing those formulas to my kids when they go to sleep. You know what? Puts me to sleep every time. Oh yeah, I get the calculus book out and start reading. It's the easiest way to put kids to sleep, trust me. I think some of you guys sitting out there believe me on that too, don't you? Hey! Only because you were up late last night.
You should have put them to
There is no rest
The best don't rest.
for us.
Those puppies are sick.
What's that? Lots of teams. I'll show you the list here. Okay, let's rock and roll here, guys. What I want to put down here is this. You might want to put down here. Guys, general formula you're going to hear me talk about today is this. Volume is equal to capital B times H. This is what we're really going to be talking about here today, right? Okay, now listen carefully on this. Okay. Notice up there all of a sudden I threw up a capital B, all right? Capital B right here. This capital B right here is going to represent an area of a base. Now our base is going to be based on what kind of a prism I'm talking about. If I say rectangular prism, what's the base shape? Well, it's a rectangle. If I say triangular prism, what's the base shape? Triangle. If I say trapezoidal prism, what's the shape of the base? If I say, what if I say cylinder, what's the shape of the base? Circle. Okay. Now this is going to be the general formula for all prisms, but I'm going to have more specific formulas for you here in a second about each one. Okay, so what you may want to write down about this formula is the following. This is the formula we're going to use all the time, but understand this. The base, the area of the base, this is just capital B, that's all it means. It's the area of the base. I'm going to write down as the area of the base shape. Okay, it's the area of the base shape. So a capital B means area of the base shape. Okay? Area of the base shape. Then, this height that I talk about, H. Where's my triangular prism at? There it is. What kind of prism is this again? Triangular prism. Okay? It's a triangular prism because the two sides that are equal and parallel to each other are the triangles. Okay? It's a one shape that I could sit like this, and the top and the bottom would be exactly the same shape, right?
Yep.
That's why it's a triangular prism. Hear me out on this. What shape would be the base on this then? Triangle. Okay? Watch what I put for height in any of these value formulas. Height is the distance between bases. Okay? The height's going to be the distance between my bases. What kind of shape is this again?
Triangular.
Triangular prism. Is my height vertical or horizontal this way?
Vertical.
It's vertical. It's the distance between the two triangles. What if I do it this way now? Triangles are here and here. That's a triangular prism. The distance between the bases now doesn't go up and down. It goes front to back. So understand this. A height, we typically think of height as being vertical, but in our situation today, the way things are laid out, that height can be something that's either vertical, like this, or if I lay it down like this, then the height, the distance between the bases runs front to back, doesn't it? Okay. So understand that H, it means the distance between the bases. Okay? In our case, triangular prism here, it's the distance from the front triangle to the back triangle. Okay, so let's take a look at what we've got here. You guys have the notes down on the first page? Okay, we've seen shapes like this before. We were concerned with the number of units on the outside, but today we're concerned about the number of cubic units on the inside. I love these problems because they're a lot easier than what we just got done doing.
I always see that in 2D.
I do too. I see this as the bottom going down, but I also see this as the bottom going back in. And it's weird if you look at it long enough, because it'll change.
It looks like an envelope if you look at it like really 2D, like a weird envelope.
You know what I see? You know what I see? I see a happy tree.
Oh, I see. I see.
I don't see it.
I see a happy tree and lots of little ducks on the pond and people at the park feeding the ducks. That's what I see.
Oh yeah, that's what I see too.
Oh, okay. I thought you were going to say something like, I see aliens or something like that. Yeah, let's not go there. Let's not go there with this class. All right, triangular prism. Here's the deal. I gave you a general formula for the volume of any prism, right? I gave you the formula for the volume of any prism. Okay, what was that formula I just gave you on the first page?
Volume equals capital B.
Capital B, where B represents the area of the base times the height. Let's dimension this thing out real quickly. I'm going to call this 12. I'm going to call the height here 10.4. And I'm going to call this depth right here 20.
Yeah.
Okay.
Yeah. I gotta tell you something.
Okay. Give me about 10 or 15.
Okay.
Or just text it to me and I'll take a quick peek.
Okay.
Okay, first of all, guys, by the name triangular prism right here, what shape's your base?
Triangle.
The triangle. So I'm going to go ahead and find capital B. I'm going to find capital B. Okay, so since this is a triangular prism right there, I want to find the area of that base triangle. Okay, do I have enough dimensions to find the area there?
Yes.
Okay, what am I going to have to do to get that?
10.4 times 2. Or no. Yes.
Okay, so I go half times 12 times 10.4, right? That's where you were going, right, Izzy? Okay, so I'm going to go 1/2, 0.5, times the base of that triangle, 12. What's the height of that triangle right there? Well, it's 10.4. I need someone to punch that up. I don't think I can do that in my head. I can try. 62.4? 62.4? Ease down, killer. How about the height? This is the part we talk about in the volume formula. That height is the distance between the triangles. So So in other words, this distance that I'm highlighting right here, that's the distance I'm talking about. How much distance between the triangles, gang? It's 20, isn't it? Okay. How much distance between my two triangles? Well, it is 20 units, right? Okay, so that makes the height 20. So guys, we found the area of the name or the base. By name, it was triangular prism. Base was what value here? Height is how much between the bases. How are you going to find the volume, kiddos? What's the formula? If your volume is the area of the base times the height now, how many cubic units would fit inside of this triangular prism? We would take the area of the base, 62.4, times the height of what? 20. Okay. Oh gosh, what is that? 1,248?
Yeah.
1,248. I won't dance about that one. That was an easy one.
Oh, yeah, I forgot.
Well, all I did is move the decimal one to the right. That's like times it by 10, right? 624, and then doubled it. Times 10 times 2, that's like times 20, right? See, I think weird like that. Almost alien-like. Okay?
If you are an alien.
Maybe I am an alien. Maybe I am an alien. Wouldn't that be funny? Cubic units. Why not square units, guys? Why cubic units? Because we're talking about the number of units on the inside. 3 dimensions on the inside, okay? Do you understand what I just did there?
Yeah.
Find the area of your base. Your base is the shape of the name of the prism. In this case, a triangular prism, so the base is a triangle. You understand that height's the distance between your bases then, right? Okay, let's look at another one. I like this one right here. I'm going to give you a shortcut to formulas on any rectangular prism. Okay? Rectangular prism sits kind of like this, doesn't it? You guys agree at the bottom could be a rectangular prism here? Believe that? Okay? Well, what shape is the bottom? It's a rectangle. Okay? How do you find the, well, I'll just draw it here quickly. How would I find the, how would I find the area of that bottom right there if I dimension this out as maybe 12, and then maybe 6, and then maybe 8? Wouldn't the base just simply be 12 times 6 here? And then what's the height between the top and the bottom? 12 times 8. So here's the deal. Here's the deal. Anytime you have a rectangular prism, I know that this is the general formula that we can use right here, but a rectangular prism can use this one right here. Anybody know it? Isn't the bottom down here a length times a width? This length of 12 and a width of 6? And I would take that times the distance between the top and the bottom, which is 8. Anytime you have volume for any rectangular prism, it's just length times width times height. This length times width right here really represents capital B. And then this height h up here is going to be the same as the height in that. So, guys, what 3 numbers am I just multiplying together for any rectangular prism? In this case, 12, 6, and 8. Okay? Would the same be true for a cube? What's true about the edges on this cube? If I told you this distance is 5, what's that mean about the width then? And what about the height? So if I give you a cube and just give you one dimension right here, you know the length is 5, and the width would have to be 5, and then the height would have to be 5. So you would go 5 times 5 times 5, which is something, 125 something, right? In this example then, we're going 12 times what?
6 times 8.
So the volume formula for any rectangular prism, what can you use actually? Length times width times height there. Okay? So in our case, 12 times 6 times 8, oh gosh, 72 and 8, 720, and 144, 150, 3, 5, 70, and 6, 576? I like 576. Go 12 times 6 times 8 again. 576? All right. 576. What kind of units? I wrote the word cubic units out here. You might want to write units like this and raise it to what power? 3. 3-dimensional. Okay. Length, width, height. Okay. Any rectangular prism.
Why do you do that?
Any rectangular prism. What's the formula? Any cube. I might just jot this down up here too, guys. Any rectangular prism. This would also work for any cube as well, right? 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 Okay. Next one I have then on your notes. Isn't it a cylinder? Isn't it a cylinder?
Mm-hmm.
Anybody need more time with that? Okay, let's take a look at my cylinder. Let me do this quickly. Let's draw my cylinder as best I can. La la la. La la la. Ooh, it's a pretty cylinder. You guys agree that the two shapes that I could sit on top and bottom would be the circles?
Yeah.
Okay. So the cylinder, capital B is really what kind of the shape? Circle, isn't it? Okay. I'll try and write this. What's the area formula for a circle? So pi.
Times radius squared.
Pi r squared, that's the base, isn't it?
Yes.
Isn't this my?
I love it, but I hate it.
Isn't that your height? Isn't that my height? If this is the area of my base, pi r squared, this is my height. Instead of having capital B times h, what could you have times h? Pi r squared times what? Times height. Yeah. So there's actually a formula for this. The area of your base is a circle, right? Right? And the area formula for a circle is pi r squared, so we could replace capital B with pi r squared. This part right down here. This part right down here is your base. That's the pi r squared part, isn't it? You guys agree? Isn't this part right up here then? Isn't that part right up here when I do this? Aren't these two base shapes the two same shapes right here and here?
Yep.
They are, right? So wouldn't the height that we were really concerning ourselves with lie right here? So if this is capital B right here, couldn't I say my volume formula for this is pi times radius squared times the height? Couldn't I? So the volume formula for any cylinder is going to be what? Volume formula for any cylinder is going to be what? Pi r squared times what? Height. So let's dimension this puppy out. Let's say the height is, I'm going to get tricky with this one. You ready? Height's 1 foot. Diameter is 8 inches. Anything alarming about the way I've dimensioned this out?
Yeah, you gotta take the 1 foot and put 12 inches.
Probably want to make sure all units are the same. So we want to change this 1 foot to what?
12 inches.
So we say hak tui, goodbye. And we call this 12 inches, right?
What's that mean?
Oh, I don't know if you guys have any, well, I don't know if you guys watch professional wrestling like I do. The ones inside the ring.
WWE?
Anybody watch WWE at all?
Yeah, I do.
Anybody used to at least?
I do.
Anybody ever remember a guy by the name of the Iron Sheik? Ever heard of a guy by the name of the Iron Sheik? You should, there's a nice documentary about him. You should watch it. It's on Netflix. If you get time, watch a documentary on the Iron Sheik, and you'll understand what it means, okay?
Parson, is it split times in that thing? Is the split times in the crate still?
It is, but they had the zones wrong last night. You were supposed to run to a yellow line and not the blue line. So you ran probably about...
That's why I ran an 11.45.
Yeah, so... But that's okay, it was still going to be good.
In what?
Okay. Let's do this. What value am I going to replace pi with for the volume of this cylinder? 3.14, right?
Times 4 squared.
What's your radius?
4.
So times 4. Really times 4 how many times?
16.
Isn't this my r squared part right there? 4 times 4? Sometimes I like to put it in like that. Sometimes you may or may not have a calculator that can square stuff out like that. So, what's the height here, kids? 1 or 12? Why choose 12? Yeah, we're in inches. So I'm going to go ahead and grab a calculator here quickly and punch all this in. So we're going to go pi 3.14 times the radius squared. What's 4 times 4 going to be then? 16. Oh, why did I put equals 12 there? I'll fix that here. Times this last value of what? Times 12. And a value I get, what are you guys getting when you punch that in? 602.88. How should I choose to label this? Okay, what is the unit for the dimensions first of all? So cubic inches, right? Okay, let me fix something here real quickly. So right here, I'm going to change this to, this should be times 12. What did we get for a value? 602 point. And then cubic inches. Okay, very good. Now guys, what if I had like a half cylinder here? Guys, if I could take this, my cup right here, and take a line and cut it right in half right here, how much fraction or how much coffee would it hold compared to what it already does? Half as much. So treat it like it's a full cylinder first, and then just in the very end you would cut it in half. If it was what kind of a cylinder? It'd be like a half cylinder. Okay, do you guys remember those 2 problems I didn't make you do on a practice for surface area that had the half cylinder sitting on a flat rectangle and then it kind of arched up? Remember what I'm talking about? Okay, so treat it like it's what kind of a cylinder first? Full, and then in the very end you would cut it in half. How come I didn't cut anything in half here? It's already a full cylinder, right? Okay. All right, one more example, and I'll turn you loose on some work here today. Any questions so far? How many would agree that, yeah, this is easier than the last section? Less work, isn't it? Okay. All right, let's get this last one nailed down. I think this is the last one, right? We're not going to do a pyramid today, so we're done after this sheet. Okay, kiddos, first of all, what kind of prism? Trapezoid. So the base shape has got to be what shape? So my base is a, so wouldn't that be the front right here? Front and the back, right? Okay, those are your base shapes. So let's get some dimensions to find the area of this base real quickly. Oh, I don't know. Let's go 8. I'll call this distance up here 6. Whoops. Call this distance up here 6. I'll say the distance between the bases on the trapezoid is 4. And then I'm going to tell you the depth here, or when we talk about height here, will be 10. Okay, no units attached to it, so we'll use the word units in the end. Okay, no special formula for this, so we've got to go back to the general formula that would apply for all prisms, which is volume is equal to the capital B, area of the base, times the height. So guys, in this case right here, capital B is what shape? Trapezoid, right? So look at that yellow trapezoid in the front. Do we have enough dimension, or enough dimensions, I should say, to area this out?
Yep.
Help me.
Half.
1/2. Okay, so what are my bases according to this in this yellow trapezoid? 8 plus? Yep. Very good. And how about the distance between the bases in the base? All right, so help me mathematically. 8 plus 6 adds up to what? 14. So help me out. What's half of this 14 right here? 7 times a 4. Capital B is what value? Guys like that? Then, talk to me about the height that I'm concerning myself with volumes. Again, understand that the height is the distance between the bases, or the distance between the 2 yellows up there. 10, right? What am I going to do with my base and height and then figure out the number of cubic units inside of this? Times them together, right? Capital B times H. What was the value of capital B clear over there on the right? 28. What's the height? What's the height? 10. What is 28 times 10? What is that product? 200 and? Okay, were there any units affixed to the dimensions up here? So just call it units. And then I better put what exponent value out here? indicating cubic units. Guys, some of these problems have specific formulas. Some of them you've got to use the general formula for, but you've got to understand that I'm looking for the area of the base. And isn't the area of the base, isn't the base shape given to you when they name these for you? Okay, so my question to you is this. What questions do you have for me about this? Feeling pretty good? Okay. Let me get you going on this assignment. That'll be due for, what is today, Tuesday?
Yep.
So Thursday, right?
Well, Friday, next Monday, last week. Yeah, but they're available.
Okay, here's what I would ask you guys to be doing. I want to go over one of the problems with you to start today, and I'll show you how this works, okay? Write this down. We're going to do page 519. And I want you to do problems 2 through 7. I want you to do number 9. Let's do 11, 12, 14 and 15. And number 19. And I want you to write down that this will be due on Thursday. And take a minute to get that down. And I want to go over, I believe it was number 6 with you today, okay? It's kind of something I didn't show you. All we did is talk about exploring how do you find value. My job today is to say, well, let's look at one of these problems together and find out what they're actually trying to come up with here. Yeah, I think a good one to talk about would be number 6. Okay, number 6. You guys okay with that? Guys, give me a second to draw number 6, would you? What in tarnation? 14th time's a charm, right? Not the best, but pretty good, right? Isn't that what kind of 6 looks like a little bit? Isn't that what 6 looks like? Okay. Guys, here's what I'm going to first of all get going with. There's a lot of information in this problem, but I'm going to start out with the basic question here, okay? Looking at that shape right there, what 2 shapes appear to be the shapes that I could stand this on where the top and the bottom would be exactly the same? Now, it's not sitting on it, that right? Well, what 2 shapes are exactly the same? The what again, Taylor? Trapezoid. Isn't this back, or isn't this front trapezoid the same as this back trapezoid here? Okay, so what kind of prism is this going to be? Trapezoidal, okay? Here's the deal in this problem right here. In number 6, they're asking us to find a missing dimension. In our case right here, they want us to find this missing dimension h. Now, mine's not drawn perfectly here, but we'll dimension it out like it is in the book. Well, if they give you this distance here of 10, is that right? How about this distance right here? How much?
30.
And is the left side 20?
Yes.
Okay, first of all, what kind of prism is this? Well, it's going to be a trapezoidal prism. This is the base shape right here where they're exactly the same, right? Front and the back are that same shape, aren't they? See it? Okay, see it? Give me a sign that you're alive right now. See it? Okay.
He said, give him a sign. And he now knows.
Okay. I like the alien green paint in there. It's cool. All right. The deal is this. We don't know what the height is right here. Isn't that what we're asked to find? Okay. Listen up on this, guys. What's the general formula for any prism today? Volume equals what? Capital B times H. Okay. What do you notice about number 6 right below that trapezoidal prism? What do they give you? They give you the volume. What do they say the volume is down here? Don't they say the volume is 5,400 cubic centimeters? Is that right? Is that right? That's what they tell you, right? Okay. What kind of prism is this again? Trapezoidal. If it's a trapezoidal prism, that means capital B must be a trapezoid. Okay, let's do some stuff. Look at this green trapezoid I have in front. Which two sides are parallel in this green trapezoid? The left and the right, or the top and the bottom? Left and right. So wouldn't that be my base 1, base 2 there? Okay, so for my trapezoid right here, I'm going to say, hey, capital B is equal to, here we go, trapezoid formula, 1/2. What are the two parallel sides length on that green trapezoid? 20 and then what's the distance between the 20 and the 10 right here? 30. Okay? Okay, I'll just tell you right here that this is all going to multiply to 450. Okay? That means that this green area right here, capital B, in that trapezoidal prism is equal to 450. Okay? So what this implies is this. This implies that I should be able to take this value, 450, times this height right here, and it should equal what volume? What volume should it equal? 5,400. Okay, so let's go back to this general formula, which says the volume is equal to the area of the base times the height. Guys, between the volume, the area of the base, and the height, what don't we know? You don't know the height. So let's plug in what I do know. Do we know the volume here? What is the volume V? What value could I plug in there? 5,400, right? Do I know the area of my base from, or was I able to find the area of the base in this? 450, right? And then the one thing we do not know is your height H. So how am I going to use that information up there with that formula and the stuff that I've substituted in to find your height? Divide. When I take this and divide by 450, I have no idea. 12? Is that right? Yay or nay? Yay? So what's this unknown dimension right here? 12 units. So if I can find the area of the base, and you know the volume, to find that unknown height, you would take this volume and divide by the area of a base. Okay? So they're going to do that to you sometimes. They're going to say, hey, here's the volume. You find the unknown dimension in this. Which means you have to find the area of the base, divide that into the volume, and you'll have it. Okay? Guys got 6 down? You okay with that? Okay, so a little bit of working backwards on stuff like that. So real quickly, I'll put the assignment up here again. It is page 519. 2 through 7, 9, 11, 12, 14, 15, 19. When's it due again? Thursday. We have 15 minutes now. I'd say get your books open and get rolling on it right now. We'll save the quick quiz for tomorrow. And questions about this at all? Any questions? Okay, again, I'll have your quizzes probably graded later